Hi everyone, it's Karl from Mantella Environmental Education again. We're in some nice ancient woodland in the autumn time, and here we're going to be looking for some of our woodland invertebrates, or as they're sometimes called, mini beasts. Now, in this part of the world, invertebrates are indeed very small and deserve the name mini beasts, but in more tropical parts of the world, closer to the equator, they can get bigger than some birds and small mammals, and so the term mini beasts doesn't really apply too well. But by invertebrates, all I mean are animals that don't have a backbone to hold their body upright like we would have, as well as other mammals and birds, fish, reptiles and amphibians. So invertebrates, instead of using a backbone to keep themselves upright and allow their arms and legs to move, they have to have a skeleton of different types. So invertebrates would be things like crabs, worms, caterpillars, butterflies, moths and other species of insects, nematodes, spiders, scorpions, ticks, lice, and all types of bugs. So we're going to have a little bit of a search around the woodlands and see what woodland invertebrates we can find. Now, it might be a wee bit more difficult to do this in the autumn time because invertebrates are what's known as cold-blooded, which is the opposite of what you and I are. We're warm-blooded, and all that means is that we can make our own body heat, and that keeps us at a constant temperature all the time. So we're usually nice and warm all the time. And how we're able to do that is every little job that our body does. So if I'm talking, I'm using my brain, I'm blinking my eyes, I'm moving my muscles, I'm breathing, my heart's beating to pump blood around my body. All those little jobs that our body does makes heat. And our body does so many things all at the same time. We make a lot of heat, and that's what keeps our body temperature constant, more or less all the time. But if you're an invertebrate, or a reptile, or an amphibian, or a fish, you're cold-blooded for the most part. A few species are an exception to this rule, but by and large they're what's known as cold-blooded. And that basically means their body isn't as active. It's not doing as many of those little jobs all at the same time as our bodies would be. And so while they can make a little bit of heat by being active, it's not enough to keep their body warm all the time. So if they're not able to make heat inside their own body, they have to get a source of heat outside of their body. And especially in this part of the world, in the temperate zone, that's from the sun. Because the sun goes down in the autumn, it's much lower in the sky during the autumn and the winter months, there's much less heat around for invertebrates and other cold-blooded animals to use as a source of heat. And that heat is also a source of energy for them. So the best way to think of how cold-blooded animals use the sun is like a battery charger. So when your phone stops working, you set it on your battery charger, it activates the battery, warms it up, fills it full of energy, and you can use your phone again. It's exactly the same with cold-blooded animals like invertebrates. So at this time of the year, they're very sluggish. They're hiding away in crevices, in rotting wood, and down in deep into the leaf litter and into the soil where it's not quite as cold as it is here in the air. And they're doing that just to keep nice and warm so they don't get frozen if there's a frost on the ground in the morning or at night. But they're also doing it to keep out of the way of predators. Because they're cold, they can't move very fast, they're very sluggish, they're very inactive, and they're sitting ducks for predators. So before the really cold weather sets in, they tend to hide themselves away in little dark nooks and crannies where they're really difficult to find. So one of the first invertebrates you'll find deep in rotting logs or buried deep under the leaf litter in woodlands, or even in damp areas of the garden, or even damp cold areas of your house at this time of the year, are these. They're sometimes called slaters, but the correct name is woodlice, and they're not really a species of lice at all. Lice have 6 legs, they're a type of insect, but these invertebrates actually have 10 pairs of legs, and that puts them in the same group of invertebrates as shrimp, prawns, lobsters and crabs, and they're all collectively known as the crustaceans. So our humble woodlice in our house or in our garden is actually a land-based or terrestrial form of crustacean related to crabs you'll find at the beach. And instead of using gills, which all the other crustacean species would use to breathe underwater, just like a fish, our little woodlice here, and this is a common shiny woodlice, one of 2 really common species we'll see in the house or in the garden at this time of the year, they actually have lungs to breathe in air just like you and I do. So they've got 10 pairs of legs, they've got 2 little antennae, just like insects, that they can use to move around in front of themselves. Their eyesight's terrible, so they use those antennae to both feel their way around and to also smell their way around. So their antennae function like our fingers to feel where they're going, and also our nose to smell if there's any food or danger or others of their own kind close by. Another very familiar invertebrate that loves nice dark, damp conditions. Deep down in the leaf litter or in amongst the mosses and rotting leaves are these, the slugs. The slugs are mollusks. So that's the slugs and the snails. And they're soft-bodied. They don't have a hard external shell or exoskeleton, such as the woodlice would have, and a lot of insects. They have a soft body. They actually have a little tiny internal shell. It's very, very small. Whereas snails, of course, have an external shell that they carry around on their back. Slugs, or most species of slugs, have a very small internal shell that you can't really see on the outside. Now, unlike our woodlice, which had 2 pairs of feelers or antennae, slugs and snails have 2 pairs of tentacles. And they have 2 longer ones on top, which feel their way around, but they also, at the very end, have 2 very simple eye spots, which they can use to detect light and big shapes. So they feel and see where they're going with those larger tentacles, and the 2 smaller ones down near the ground are used to feel and to smell. So that's their sense of touch and their sense of taste. And that helps them to find somewhere nice and moist and cool to hide. Their eyes allow them to get out of the sunlight because, of course, there's lots of predators like birds and hedgehogs and badgers that would eat slugs. So they're perfectly adapted for life in cool, dark environments. That's why you usually see them out in the garden on a moist, humid night in summer or early autumn. So they really like a lot of humidity when it's not too cool. And these tentacles can actually be retracted in their head, which is rather bizarre. So if a bird pecks at them, because they move more than the rest of the slug, and they attract the attentions of predators like birds, if a bird accidentally pecks one of those eyes or tentacles, they can be retracted into the head to protect it from further damage. And how the slug breathes is actually through a hole on the side of its body. You can't really see it at the moment because it's not open. But occasionally, if you watch slugs very carefully, they will open that pore on the side of their body. And it's usually right about here. They'll open it every now and again. That will allow them to breathe. So they breathe through a hole or a pore on the side of their body rather than through their mouth. And their mouth is actually underneath the front part here, underneath those lower tentacles. And it's on the bottom because they'll actually, as they're slithering across the surface of something like moss or a decaying leaf, they'll use that mouth to rasp away at their food. They'll rasp little holes in it, and their tongue inside their mouth is quite rough, like a nail file, and they'll use that to rasp away at their food. So if you come out some morning in the summer and you have lots of holes in your garden plants, it's been rasped away and eaten by things like slugs and snails. And the slime trails that they leave behind are also very important. So if this slug gets a little bit lost, it can find its way back home by following its own slime trail. All it has to do is turn around and follow the slime trail back to where it started again. And that's how slugs and snails often find their way back to a favourite resting spot in your garden at the end of the night before the sun comes up. And the slime that they use to slither when they're out foraging like this is actually quite thin, so they can glide over it. But they want to climb up the wall of your house or up the side of a tree. They'll produce a thicker slime, which makes it a lot easier for them to stick onto vertical surfaces and not fall off. And you'll see their body is also quite moist. It's also covered in a slime. And that stops them drying out in really warm weather in the summer. But it also makes it really difficult for predators like hedgehogs and birds to actually get a hold of them. When they capture them, they actually slip out of their beak or out of their mouth very easily. So they're very well adapted to avoid being eaten when they're most active in the summer months. Now, an insect that should be quite familiar to most of us is the earwig. And these are insects. You can tell they're insects because they have 6 legs. So all the insects, which are the largest group of invertebrates in the world, there are hundreds of thousands of species at the very least. all have 6 species of legs. Now woodlice, they have tiny little forewings. So if we look at the very back, you'll see those pale coloured areas just behind the head. They're the front wings, and they're quite hard and they're very short. And they actually cover papery hind wings that they have folded underneath. When they want to fly, they open up their forewings, those hard forewings, and the papery hind wings stretch out and they can fly. So that's how they get from one habitat to another. And they're omnivores. So that means they eat a little bit of everything like most people do. So they'll eat some animal material. Maybe they find a dead animal, a dead insect in the woods. And they're also plant eaters as well. Now woodlice will eat a lot of decaying vegetable matter. They're primarily plant eaters, they're herbivores, but our earwig is an omnivore. It eats a little bit of everything. But in your garden, they're rather partial to eating holes in leaves and flowers of our ornamental plants. So if you come out in the morning and see lots of holes in your flower petals, it's probably been caused by an earwig. And our little earwig's disappearing under the leaf at the moment. Now this is a beetle species known as a rove beetle. And amongst the insects, the beetles are one of the largest families of insects in the world. They have many, many thousands of species all across the world. We have quite a few hundred here just in Ireland alone. And these long, thin species, which are usually very, very dark, almost black in colour, are called the rove beetles. And this is quite a small species. And beetles are largely carnivorous. The rove beetles certainly are carnivorous, but some beetles will be herbivores or omnivores as well. They'll eat some plant material and a little bit of everything else. But rove beetles are predators, so they'll hunt down other insects and other small invertebrates to eat. And to help them do that, they have to move very fast. So predatory invertebrates tend to move very fast, whereas invertebrates that tend to be prey animals tend to be a lot slower. So their speed and their powerful legs allow them to literally chase down their prey. And they'll also use those beady antennae that you can see the little rove beetle moving around. They'll use those to track down their prey. So a lot of invertebrates, as they move around, they'll leave a little scent trail behind them. And that can be picked up by beetle predators, such as our rove beetle here. And another very common family or group of beetles you'll find in woodlands, and even in your garden, are the ground beetles, or sometimes they're called the carabid beetles. And these are predatory beetles as well, just like our rove beetles. And beetles, if you look very carefully at their legs, they have little bristles, especially on the front legs, that form a little notch or a hook. And they'll use that to clean their antennae. So as they move their antennae around, they get covered in all sorts of muck and dirt as they're sniffing and smelling and feeling where they're going. And they'll use those little notches in their forelegs to clean their antennae periodically. And you'll also see they have beautiful stripes on the back of their body. They're called elytra, or wing cases. They're very hard wing cases that cover their thin papery wings which lie underneath. And again, just like the earwig, they can fold out those papery wings when they want to fly, and that will allow them to travel from one habitat to another. They've also got incredibly good eyesight, as well as incredibly good sense of touch and smell through their antennae, and that's how they're able to track down smaller invertebrates to catch and eat in areas like woodland and our gardens. Here we have two invertebrates that are definitely not on everyone's favourite list. They're of course the spiders. And spiders belong to a group of invertebrates called the arachnids, all of which have 8 legs. And that includes the spiders, the scorpions, the mites and the ticks. So they all have 8 legs. A lot of people find them very creepy, but they're actually very beneficial. And spiders, of course, are purely carnivores. They're pure meat eaters. There are no species of spiders that are omnivores or herbivores. So these are built to be predators. And to have that, they have 2 fangs. In some species, they can be whopping great big fangs. But in these 2 particular species, a little orb web spider and a mesh web spider, which you find quite commonly in your garden and around your house, the fangs are quite small. And of all the spider species, several hundred that we have in Ireland, it's only about 10 or a dozen species that have fangs that are sufficiently large to actually penetrate human skin and give us a bit of a nip. So the vast majority of spiders you'll come across outside of your own house or your garden are perfectly harmless. They can't actually bite you at all. Their fangs are too short. Now, unlike our insects, such as our rove beetle, our ground beetle, and our earwig, which had 3 body sections, they had a head, which was the smallest part, a thorax, which is where some of the organs and the wings are attached, and an abdomen, which is usually the largest part where their guts and their breathing pores and their eggs are all situated. Spiders only have 2 parts to their body. They have a head, which is joined to the thorax in one body segment, and then a big abdomen at the end. And in spiders in particular, in most species, the males and females look physically different from each other. So this little orb web spider is a female, and I know that because she's got a big plump abdomen for her body size. Now, female spiders have that bigger abdomen to store more eggs. And the males, this is a little male mesh web spider you'll find quite commonly under windowsills and places like that around your house. He has a very small abdomen. That's because he doesn't produce eggs. So the general plan for most invertebrates, spiders included, is to lay as many eggs as they can, which then hatch into sometimes hundreds of spiderlings. And the reason why they have so many young is that most of those young will either starve or get eaten by their brothers and sisters, or even other spiders or other invertebrate predators. So if you have dozens, sometimes hundreds of young, some of them are bound to survive into adulthood themselves and carry on the species. So females within a species of spider also tend to be a little bit larger as well, again to help them carry those eggs around. The males tend to have a smaller body overall, but much longer, more gangly legs. And one of the reasons for that is probably to get away from the slightly larger females, because in some species of spiders, the females eat the males. And that's not as bad as it sounds, because usually the male dies within a year in this part of the world anyway. So if the female doesn't eat the male, he'll die of cold and old age anyway. Now, another invertebrate that has 8 legs that you might come across in your garden, especially on the walls at this time of the year where they can try and absorb some heat from the sun early in the morning, are Harvestmen. And they're so called because they're most commonly seen in late summer and early autumn around harvest time. And they have 8 legs, but they're not actually a spider. They are an arachnid, but they're in a different group to the spiders. And Harvestmen also have 2 body segments. They have that big plump abdomen, where in the females the eggs are stored and laid, and they have a head at the other end. And they have no silk glands at the end of their abdomen to spin a sticky web like true spiders do. And Harvestmen also have much longer, skinnier legs than spiders. And it's usually the second pair of legs are much longer than all the others. You can see that quite easily in these 2 Harvestmen. So the second pair of legs are much bigger than all the others. And the front pair of legs, as well as the second pair of legs, are usually used to feel their way around, because their eyes are small and their eyesight is pretty terrible. And their eyes are actually oriented at the side of their body. So they're actually designed to see perhaps predators coming from the side, whereas their long legs act like antennae to feel to the front as well as to the side, so they can feel where they're going and keep their eye out for danger at the same time. Now, because they don't have big, powerful fangs to protect themselves and to catch their prey like true spiders do, instead, another way that Harvestmen protect themselves is by producing really nasty, noxious chemicals which smell and taste disgusting. And if a bird, for example, or a larger invertebrate such as a spider was to disturb our Harvestmen, they could produce that really bitter tasting substance, and that would stop them getting eaten by predators. And Harvestmen, such as this little species, are actually omnivores. They will eat some plant material as well as being predatory as well. And they're also scavengers. So if they come across maybe a dead invertebrate or other animal in an area of woodland or in your garden, they'll also scavenge some of the meat from that as well. Another group of invertebrates that are very common in and around the house and the gardens at this time of the year, but also in woodlands like habitats and amongst the leaf litter at night time, are the millipedes. And the word millipede actually translates as 1,000 feet. because people used to believe they had as many as 1,000 legs. And they certainly can have quite a few hundred. The record is 742 legs. So they have quite a few hundred, but not quite 1,000. And you can see they look a little bit like a worm, especially when they're resting like this. They're all curled up. But unlike worms, which are soft-bodied and use fluid inside their body as a form of skeleton, millipedes have a hard exoskeleton on the outside of their body. So it's like having your bones on the outside rather than on the inside. And that gives them protection from predators, as well as helping them to stay nice and moist on the inside, not dry out if it's really warm in the summertime. And these two very small millipedes are actually introduced species. They're not native to Ireland. They were introduced from New Zealand, probably in horticultural produce, so pot plants that came from New Zealand or something like that. But although they're classed as non-native species, they're not really that invasive. I don't think they do that much harm to the environment. And they're quite a small, pale, buff-coloured species. Now, some people confuse millipedes with centipedes, and there's a very important difference. Especially in this part of the world, millipedes are vegetarian. They're herbivores, so they eat both live and especially rotting plant material. And to do that, they have little blunt jaws that they can use to scrape away holes in rotting leaf litter, for example, or rotting wood. And when they do that, they're not actually eating the wood. They're eating the fungal hyphae, the little white threads of fungi that go through the rotting wood, and that's actually what they're eating because there's lots of nutrition in the fungus. Centipedes are predators. They have two whopping great big jaws and they are venomous. So even the centipedes you can find in your garden can give you a bit of a nip if you try to catch them. And because they're predatory, they're very fast. Millipedes are very slow. Because the plant material doesn't run away when they try to eat it, they don't need to move fast at all. So as well as eating different things and one moving fast and one moving slow, what's the other difference between millipedes and centipedes? Well, millipedes have 2 pairs of legs for each of those little body segments that you can see, whereas centipedes only have 1 pair of legs. So the word centipede translates as 100 feet. And I don't think there's ever been a species of centipede found with as many as 100 feet. They usually have 30 or 40 feet. So not quite as many as our millipede. And our centipedes can use those big venomous jaws to protect themselves as well as to catch other invertebrate prey. But our millipedes protect themselves by hiding away during the daytime, by being cryptically coloured like rotting leaves or wood, by curling up and using their hard exoskeleton as a shield. And they can also, if they're really harassed by a predator, produce really smelly, bitter substances that can deter predators, just like our harvestmen did. So they can use chemical warfare to protect themselves. Something else you can often find in the autumn, especially when it's really, really wet during some of the autumn storms, are these earthworms. And this one's about 15-20 centimetres long. And the soil is so saturated with water that it's actually come out of its little burrow in the soil and it's crawling across the ground to go hopefully find a patch of soil that's a little bit drier. How cool is that? Now these are very, very important for the health of the soil in places like the woodland where we are now, and also in your garden. And by digging through the soil, they allow lots of air down into the soil, which is of course is what plants need around the roots to help them grow. So without earthworms, all the soil in our gardens and in the woodland would be very, very poor in nutrients. Wouldn't have a lot of air in there, wouldn't be a very good place for plants to grow. So that brings us to the end of our video looking at woodland invertebrates in autumn time. It can be a little bit more difficult to find them at this time of the year, but you can find them especially on mild days through autumn, winter into early spring. And any day when the air temperature is kind of above about 5 or 6 degrees Celsius, you can get out and some of our mini beasts will be active. At temperatures lower than that, it's just too cold for most of them and they'll remain hidden away. And even get out into your own back garden at night time, as soon as the sun goes down, unless there's a really hard frost or it's really cold, you will find a lot of the mini beast species covered in this video as well. So happy mini beast hunting.